So this nice figure I took from the WHO previous edition, 4th edition book. We have central lymphoid tissue and peripheral lymphoid tissues. Progenitor T-cell prothymocyte in the bone marrow has two different ways to go. It can become a natural killer cells and goes directly into peripheral lymphoid tissues, or the progenitor T-cell prothymocyte in the bone marrow can enter the thymus and become a subcapsular cortical thymocyte, or they can become a natural killer cell and enter the peripheral lymphoid tissues. So this thymus is an important organ for T-cell development and for our immune system. It sits in the mediastinum just above the heart, and it's usually bigger in the kids and getting smaller while your age. This first cell in the cortex is double negative cell. Double negative means those are not expressing either CD4 or CD8. They also has an immature T-cell phenotype. That means those are CD1A positive and TDT positive. We also get rid of self-recognizing T-cells in the cortex with the help of thymic cortical epithelial cells. And then these cortical thymocytes also have two ways to go. They can become a gamma delta T cell, or they can go into the medulla of the thymus and become an alpha beta T cell. We have basically two different T cell subtypes. These are alpha beta and gamma delta. The majority of them, 95% of T cells, are alpha beta T cells. And in the first cell, common thymocyte, these are actually double positive, CD4 positive and CD8 positive. In this stage, they can die, or they can become medullary thymocytes, which those are single positive. That means either CD4 positive or CD8 positive. When we look at the peripheral lymphoid tissues, let's start with natural killer cells. But before going into the natural killer or gamma delta T cell, I'm gonna just briefly remind you about the importance of or differences of innate immune system and adaptive immune system. So we have basically two immune system. Innate immune system is the most quick one. They don't require antigen presenting cells, and they don't require antigenic memory, and they are the first barrier, first defense system, and the cells of the innate immune system are natural killer cells, gamma delta T cells, granulocytes such as neutrophils, eosinophils, basophils, and monocytes. So these functioning in the spleen, mucosa, peripheral blood, skin. Adaptive immune system is more slower, and their player are B lymphocytes and T lymphocytes, and they require antigen presenting. They require memory B or T cells. So these natural killer cells arising from the common progenitor T cell, but the one important thing is they don't express CD3, but they express CD16 and CD56. And also gamma delta T cells usually don't express CD4 or CD8 or CD5. When we look at here, we have CD4 and CD8 naive T cells. So when they expose to antigen, they can become T blasts. And as you know, these are usually called cytotoxic T cells, and these are usually called helper T cells. So with the help of different cytokines, they can become a CD4 T helper 1 or 2, T regulatory, or T helper 17. And another class of T cells is called T-follicular helper cells. These are literally helping the B cells for the in the germinal center of the lymph node to help their function as a germinal center B cell. And for the T cells, they have memory T cell and effector T cells, and they can have granules in their cytoplasm. And the lymphomas arise from central lymphoid tissue is usually called T-Lymphoblastic Leukemia lymphoma, TALL. And from the peripheral tissue, we usually see peripheral mature T cell or NK cell lymphomas or leukemias. One important difference between lymphomas arising from the cells in the innate immune system is usually extranodal and usually seen in the pediatric age group, but as opposed to innate immune system, adaptive system lymphomas like mature T cell lymphomas usually seen on older